Hi everyone, in this video I am going to explain tetravalency of carbon and the arrangement of atoms on carbon, the shape at carbon atoms. The first tetravalency of carbon. Carbon has tetravalency. The valency of carbon is 4. It can form 4 covalent bonds. So what is the electronic configuration of carbon? If you see electronic configuration of carbon, after helium, atomic number of carbon is 6. Atomic number denoted with Z. So what is ground state electronic configuration? After helium, 2s2, 2p2. 2p2 means 2px1, 2py1, 2pz, 0. So when carbon atom absorb energy from any source, electron present in s orbital excited to jumps to p orbital. That is called first excitation. So first excited state electronic configuration of carbon is, so in first excitation state also atomic number is same, only the change is electron jump from 2s subshell to 2p. So 2s1, 2px1, 2py1, 2pz also become 1. So by participating one s orbital and one p orbital, it involves in sp hybridization. Carbon can also involve sp2 hybridization by involving one s orbital and 2p orbital. Carbon can involve sp3 hybridization also. sp3 hybridization. But there is no chance to carbon to involve sp3d hybridization because there is absence of d orbital. D orbital are absent in second shell. That's why carbon cannot involve d subshell, d orbital in hybridization. That's why we can only see sp, sp2, sp3 hybridizations for carbon atom. So carbon cannot involve sp3d hybridization. Carbon cannot involve carbon can involve sp, sp2 and sp3 hybridization. sp3 hybridizations in first excited state. Carbon cannot involve sp3d, sp3d2 and sp3d3 hybridization due to absence of d orbital in its valence shell. Due to absence of d orbital in its valence shell, carbon cannot involve d subshell. d orbitals in its hybridization. So if you see shape of shape at carbon atom, so if hybridization of carbon is sp, shape of arrangement at this carbon linear, sp2 carbon trigonal planar. If carbon involve sp3 hybridization, then the shape of molecule is tetrahedral, because in sp hybridization, two hybrid orbitals, two p orbitals. So these p orbital participate in pi overlapping and hybrid orbitals participate in sigma. So in sp2 hybridization, three hybrid orbitals, one s orbital, two p orbital, total three hybrid orbital, and one p orbital. This p orbital involve in pi and hybrid orbitals involve in sigma bonding. In sp3 hybridization, there are four hybrid orbitals, 0, no p orbital, all are sigma bonds only. That means how many sigma bonds it can form? 4 sigma bonds. So see this table, by counting number of sigma bonds we can assign hybridization. So this is in short form. I am going to write in short form. Hybridization then number of sigma bonds. By counting number of sigma bonds we can assign hybridization. And shape of arrangement of atoms. See this. So if number of sigma bonds are 4, hybridization of carbon is sp3. Number of sigma bonds are 3, hybridization of carbon is sp2. Number of sigma bonds are 2, then hybridization of carbon is sp. If hybridization is sp3, shape of arrangement of atoms on that carbon tetrahedral. And if hybridization is sp2, shape of arrangement of atoms on that carbon trigonal planar. If hybridization of carbon sp, arrangement of atoms linear. So the arrangement of atoms on carbon atom only 3 types. They are tetrahedral, trigonal planar, and linear. See this. If you see in methane or any other, there are 4 bonds, or like this in carbonyl carbon. Examples. Next, in cyanide. Okay, so calculate number of sigma bonds here. Number of sigma bond. So only one bond sigma, one bond sigma. So one bond sigma. In a double bond, one sigma, other is pi. So this is one bond sigma, triple bond, one sigma, 2 pi bonds. By count number of sigma bonds here on each carbon. On first carbon, number of sigma bonds are 4. Therefore, hybridization is sp3. And here number of sigma bonds are 3. 4 sigma bonds. Here number of sigma bonds are 3. So sp2 hybridization. Here number of sigma bonds are 2. So hybridization of carbon sp. Thus we assign hybridization to the carbon atom and shape of the molecule. So what is shape of molecule here? sp3 hybridization, tetrahedral. Here arrangement of atom, trigonal planar molecule, and this is what? Linear molecule, right? Thus we assign hybridization and shape of arrangement of atoms to the carbon atom. Hope you understand. Thank you.